Hello everyone and welcome. Today we're diving into a super interesting topic, the product of two vectors. Now I know what you might be thinking. Multiplication? What's the big deal? But trust me, with vectors, it's not as simple as 2 into 3. Here, direction changes the whole game.
So, you've totally mastered adding vectors and you're a pro at subtracting them. But what happens when you need to multiply them? I mean, if you just multiply their magnitudes, you lose all that important direction information, right? And that's the whole point of a vector. So, how do we actually do it?
Well, here's the cool part. There isn't just one way to multiply vectors. It's kind of like a video game, you know? You have to choose your game mode before you start the level. There are two completely different ways to do it, and each one gives you a totally different result for a very different purpose. So here's our game plan for today. We'll explore the two types of products. First, the dot product, which I like to call the alignment score. Then the cross product, which is our combo attack. After that, we'll put them head-to-head to see the key differences, and finally, check out how they unlock some real-world power-ups. Let's get into it.
Okay, first up is the dot product, which is also called the scalar product. The best way to think about this is like checking the alignment score between two players, or in our case, two vectors. It basically tells you how much one vector is pointing in the same direction as the other one.
Now, this is the most important thing to remember. When you calculate the dot product, the answer isn't another vector. It's just a plain number, a scalar. It has a value, sure, but zero direction. You combine two vectors and, poof, the direction just vanishes, leaving you with one simple number.
All right, here's the official NCERT formula. The dot product of vector A and vector B is the magnitude of A times the magnitude of B times the cosine of the angle theta between them. That cosine part, that's the real magic here. It's the mathematical heart of our alignment score.
But look, forget about finding angles for a second. The way you'll actually calculate this is much easier. If you have your vectors in the I, J, K component form, you just multiply the matching components, I with I, J with J, and K with K, and then just add those three results up. Simple as that. This is the direct way to get that alignment score.
0. So what's so special about this number when we talk about dot products? Well, let me tell you, it's a massive clue. It tells you something really important. See, if the dot product, the alignment score, is 0, it means the vectors are perpendicular. They're at a 90-degree angle to each other. In our game analogy, one player is moving forward, and the other is moving completely to the side. They aren't helping or hurting each other in that direction at all. This is a super important property. You have to remember this one.
Okay, time to switch game modes. Let's talk about the cross product. This one is not about alignment. It's about creating something totally new. Think of it as a combo attack, where two different powers combine to create a third, completely unique effect.
And here is the biggest difference from the dot product. The cross product doesn't give you a number. It gives you a brand new vector. This result has its own magnitude and, more importantly, a totally unique direction that's different from the first two vectors you started with. So, where does this new vector actually point? For that, we use something called the right-hand rule. If you point your index finger along the first vector, A, and your middle finger along the second vector, B, then your thumb will naturally point in the direction of the new vector, A cross B. It's always perpendicular to the first two vectors.
Now, what about the magnitude, the length of this new vector? The formula looks a little familiar, but there's a huge change. It's the magnitude of A times the magnitude of B times the sine of the angle between them. Remember, dot product used cosine because it cared about alignment. Cross product uses sine, which is at its maximum when the vectors are perpendicular, creating the strongest combo attack.
So, the easiest way to actually calculate the cross product is by using a 3x3 determinant. It's pretty straightforward. You put I, J, K in the top row. Then the components of your first vector, A, go in the second row, and the components of B go in the third. Then you just expand it. But be very careful here. Remember the signs. It's plus, minus, plus. That minus on the J component is a classic trap where so many students make a mistake, so watch out for that.
All right, we've played both game modes. Now let's put them side by side in a final showdown just to make sure the differences are absolutely crystal clear in your mind. Just look at this table. First, the result type. Dot product gives you a scalar, just a number. Cross product gives a whole new vector. Now, is the order important? For the dot product, nope. A dot B is the exact same as B dot A. But for the cross product, yes, absolutely.
A cross B is a negative of B cross A. They point in opposite directions. And what about a zero result? For the dot product, 0 means perpendicular. For the cross product, it means they are parallel. They are literally the opposite conditions.
So, you might be wondering, why do we even need two different game modes? Well, it's because they unlock some seriously powerful abilities to solve real problems in physics, geometry, and engineering. Let's look at a couple of these power-ups.
The dot product power-up is a huge deal in physics for calculating work done. You see, work is just force dotted with displacement. It perfectly measures how much of your force is actually aligned with the direction you're moving. And the cross product power-up, it's a lifesaver in geometry. The magnitude of the cross product of two vectors gives you the exact area of the parallelogram they form. How awesome is that?
Phew, okay. That was a lot of information, but you've done a great job keeping up. Let's just do a super quick recap of the main highlights to make sure it all sticks.
So, just remember this. Multiplying vectors means you have to choose a mode. Do you need an alignment score? Pick the dot product. It gives you a scalar, a plain number, and if that number is 0, it means the vectors are perpendicular. Or, do you need a combo attack to create something new? Then you pick the cross product. It gives you a new perpendicular vector, and if the result is a 0 vector, it means the original vectors were parallel.
And that's pretty much it. So I'll leave you with a final thought. If you were actually designing a game, what kind of situation would you create where you'd need to use the dot product's alignment score check? And when would you need to unleash the cross product's combo attack to create a new effect? Give it some thought. Thanks so much for joining me.